Hey, good morning. Welcome to the Dev Talk Show. It is Thursday, December 18th, and we're going to continue what we've been working on the last couple of shows around MonoGame. And before we get started into that, as always, introduce my co-host, Chris. Chris, how we doing?
Good morning. 1 week till the holidays here, huh?
Yeah. This time in the morning next week, we will all be waking up groggy-eyed and with kids all excited if we have those at home. So,
Yeah, that's right. That's right.
and maybe even grown-ups too. Who knows?
Yeah, that's true. No, it's great to be here. We last time started. I think really it was kind of like a restart of development with MonoGame. There's a couple shows that you may see in our backlog on this,
Mhm.
but this time we're driving towards something playable, something that we can actually start seeing. Not just our main character moving around on the screen, but the interactions you see in a game. And this is all based on my very first Philly.net talk back in.
Oh, nice.
I'm not exactly sure. I tried to remember what the date is on this. It might have been 2009. I'm not 100% sure.
Wow.
But it was around the time that Windows Phone was coming out. And so it was a hot topic at Philly.net Code Camp. And we are essentially rebuilding that game, warts and all. And then what I think we're going to do after that is after we just get it working, then we will investigate some refactoring to move it into the future. Because what never happened in that talk is like complete state management of the game, where you might have an opening screen and a game over and that kind of it. That
Right.
wasn't ever part of the demo, so we'll be able to add all that. Our
Kind of
producer-
round things out, make it a more polished game with those
Yeah.
beginning and end pieces, right?
Yeah,
Cool
I think we have
stuff.
to do that. So I wasn't sure if I had to let the show producer out of the room. That may still come. I don't know.
Okay.
He's going to be indecisive because as we head towards break, there's more folks in the house than usual. So,
Oh, okay.
All right. Let me.
All right.
Oh, I need
Turn
to.
it over to you. Let's see.
Yeah. Well, first I need to
share your
present.
screen.
Yeah,
Yeah.
I haven't done that yet. So I'm going to go ahead and share the system audio, but I'm not 100% sure. If you hear me doubled, let me know, or if anything, or if you hear yourself doubled.
Okay.
The only reason I say that is because StreamYard warns against it.
Mm-hmm.
But I don't know if the way we set up our audio, that happens or not. I don't know.
No. All right. This will be interesting.
Okay. So this is where we left off. We have our main character drawn on the screen with a tiny bit of code in our update method. The four methods of XNA's game class: initialize, load content, update, and draw. And right now, update and draw are, as fast as it can go, are cycling around in a loop. Update, draw, update, draw, update, draw. But it isn't that exciting, because what's happening is update is not changing any of the game world state. It's not moving this clown or anything. And draw is just doing what it's told, which is what it did last time. However, there's a little bit of code in here that kind of allows the game loop to proceed if I hit the space bar. So if I hit the space bar, then we saw that for now, just to facilitate testing, whenever the clown hits the bottom, which normally in the game would be like you failed, you've lost a life type scenario. Instead of crashing, he just bounces, and you're going to see later that actually it's just a simple way for us to kind of keep things moving while we're testing and working. So that's it. That's all that's happening. But it's the beginnings of what I like to call like building the toy in game development.
Okay.
Not all games are this type of game, but essentially this is the kind of a game where you build a state machine, a world of even like I'll use the term loosely, a physics model.
Yeah.
And then once you have that working, it plays itself. It's not like maybe other games where it's an if this, and once they reach this point, and then when they reach that point, and then when they pick up the quest item, that's a different kind of state machine. But in the end, game development is update and draw, and so it's not really all that different.
Yes.
We happen to be in Visual Studio 2026. I believe I started this as a .NET 8 project.
Okay.
We may very well change it to .NET 10 later. That's really not super relevant, so I'm not going to worry about it too much.
Right.
But
It's not features you're taking advantage of by doing that, right? It's just kind of keeping up to date.
yeah, and the other thing is that, so I will say this though, is that I was tinkering around with some new language features, and those may come into play. For example, there's some features to auto-implemented properties, which that's the fancy C# term for how you can declare a property and just put get set, and it takes care of the backing fields and everything for you.
Yep.
But for many years, we as C# developers, if you've ever wanted to step even a tiny, tiny bit outside of that box, you had to go back to the private backing field and dismantle it all to the quote unquote original way. And there's some new features in C# 10 that sort of say like, no, you can still stay within the lines. We've added some new stuff to help you out. And I tinkered with some of those. And so maybe at some point we'll say, look, listen, we like some of the new language features. Let's move. But here we are. Again, program CS, not super important. Everything is happening in the CircusPop game class, which is just me taking game 1 CS and renaming it, derived off of game. This is kind of how you get started. And we even built a little sprite class that manages keeping together a texture with position and velocity. Right now, these are public, meaning that, like, you know, if we're going to be like purists about language design, obviously anybody can reach in here and alter these things, including the game class. But I think we'll get some work done in here. I think even later, even after we get things working, to kind of give us a place to manage not just sprite management, but even animation management. I think we'll be able to do that. So I'm gonna pause for just a second because I'm getting asked to open. This might be a little bit of a back and forth here, so I don't know.
Okay, all good. Chris is going to do some logistical management there. So if you're watching, welcome. Love to have you here. We're trying to get going through this game that Chris has created, and feel free to ask your comments, ask your questions. MonoGame is something that is a little bit new for me. Tried out some of the XNA stuff in the past, but this is a chance for us to kind of see what's new and popular. And MonoGame you can port to pretty much any platform, from what I understand, right? You can do it in Linux, you can do Mac, you can do Android, iOS, right? It's a common.
Yeah, there's Android, iOS support. There are Xbox games, all kinds of cross-platform games built with MonoGame. So, you know, like I said, it's sort of XNA lived on is what. In fact, they even use, as we talked about in previous shows, the namespaces are still there. It still says Microsoft XNA. So. Cool. In any case, the next thing we need, okay, so it's not much of a game with a clown bouncing up and down. We need something for it to direct it. And when you saw the Circus Atari video, it was 2 clowns moving a teeter-totter back and forth. Now, I was doing this as like a demo to the world of how to make your first game for Windows Phone, frankly. And so I took a little bit of a simpler route. I should have had, let me see, do I have a lot of these things ready? Okay, I do have a lot of these assets ready, which is good. So
awesome.
Let me go. I wanted to make sure that I had this all set up. I have, and this is hand drawn. The clown, I actually, I compiled it from some sources and then did a little bit of Photoshop editing myself that you'll see a little bit later. But this was me. This was 100% me.
Oh, wow.
I went in, I mean, the magnificent, I'm so great with drawing tools. I just went into like, I don't think it was Microsoft Paint. It might've been paint.net. And I drew this, and this is a trampoline. I have to say that for everybody. And I even have to make sure that I called it trampoline, because that way you'll know that it's a trampoline and not whatever you might have thought it was when I dropped on here. So instead of having the 2 clowns moving back with a teeter-totter, which I think is somewhere we could get eventually, I was trying to keep it simple. So how do we add that to our project? What I'm going to do is I'm going to open the content management editor. And one way to do that, because I have the Visual Studio extension installed, I can just double click on the content file in our solution. And then opening up on my main screen was the MonoGame content editor. And we see earlier, we have clown.png in here. And now I need to bring in this other one. So I'm going to say add a I'm going to say, oh, actually, no, what I want to do is I'm going to right click on the content project. I think there's other places to do this too. I'm going to say add existing item. And yeah, I'm where I want to be here. So I'm going to say, come back. Wait, hold on. I've got a lot of folders with different things.
There we go.
So here we go. Source, content, trampoline. Now it's telling me, it says, yeah, this file's somewhere else. Do you want to copy it here? And I'm going to say, yeah, I do. I do want to copy it here.
Okay.
I'm actually going to rename it just for consistency's sake. I'm going to rename it so it's a lowercase. That's not required. I want to make that totally clear that that's not required. And then I often forget to do this. I'm going to save the project. So the little star went away. And I'm going to build the project.
Okay.
So we have now built. It says I've already dealt with clown.png, and now you're building. The reason I'm using PNGs, I'm taking advantage of PNG's built-in transparency.
Yeah.
Not something we game developers had very early in writing games. So we often had to remove the pixels that we wanted to be transparent ourselves. And the cool thing is MonoGame does that for you. So but we don't have to worry about it on this one. So just like you saw up here, I loaded in a clown texture that I made part of game one. Now, if you're watching and you're an experienced C# developer, by the end of when we get this working, you may be a little dismayed that like it's all in the game class. Is that required? No, we can be very object oriented and clean about all of this. Remember that this was a demo, and I wanted very much to focus on game development and worry less about the prettiest like software design you've ever seen.
Right. All the clean code stuff.
But we'll work on that here, because the reason why is if for a small game like this, you can probably get away with it. If you're going to make a much larger game, you'd go crazy trying to just keep it all in one file. So
right.
So I'm declaring a place to bring in that texture. Now let's come to load content, and let's actually bring it in. So just like loading the clown texture was that easy, I'm going to say the trampoline texture, let's load it in using content.load. This is all built into XNA. It knows how to handle PNGs. It uses the same name that I gave it in the content pipeline with that lowercase t. And then we're going to want to position it on the screen. So let's...
So it's the name of the file basically without the extension is what I...
Yes, you don't have to supply the extension. I suppose we could test out that supplying the extension just to show... because like I said, the reality is that it doesn't really I think you can add it and it's no big deal.
Okay. I mean, that would make sense.
Yeah, just so you know. So let's see. We want to get it on screen here, and in order to manage it, just like we had a clown position, for now I'm going to just add a texture. And now you could be asking a very good question, like, well, why don't you just use the sprite class? And it's mainly because for interest of time, I'm going to stick to the way I did this demo. But part of what our refactoring will be is like, well, let's do it better, right? So let's see. We're going to need to declare a trampoline position. Now let's head down to the update class. What is this update class missing? Frankly, it's missing state management. Games often are state machines, and you move from one state to another. That's not really being done all that well here, unless you kind of consider that we have that Boolean is game started. And so every time we come into update, we come in, the first thing we're doing is we're grabbing the state of the gamepad and the state of the keyboard. So if we examine these data structures that come back, we would be able to walk through it and be like, well, is the A key pressed? Is the K key pressed? Is the Shift key pressed? Are buttons on these controllers pressed? And so every frame you're grabbing the current state and then deciding what does that mean for my game world.
Right.
We just do that real quick. we double check, did you press the back button on the controller or did you hit escape on the keyboard? If you did, we're just going to close the game. So that's like our way out.
Yeah.
Then, well, has the game started? Because we are initializing this game with game started as false. If it isn't, then first let's check to see if you intended to start the game by either hitting the start button on the controller or the space bar on the keyboard. And if so, we're going to flip this. And that will allow us to run through the rest of the update section. And actually the toy begins to work. Otherwise, we just return. We just skip all of it. So that's all that is doing.
Okay.
I'm going to sneak in and kind of hijack this by saying, well, if the game hasn't started yet, then why don't we also, since we're here, why don't we also set the trampoline to a starting position?
Okay.
This is not the best way to do this because, like I said, in the future, I think we're going to want state management. I let Copilot give us a good comment for this. I think we're going to want state management, and what you'll see in the future is we will probably have classes for each state derived off of some kind of state class, and what that will allow us to do is to build methods in that class that basically say, well, here's what you have to do to enter the state. Here's what you have to do when you exit the state, and here's the update loop when you're in the state. And that'll give us all the control we need to set things up, to tear things down, and to move between high score menus, exiting, game ended, game started, stuff like that. But for now, this is sort of like, well, the game hasn't started, so let's just move the trampoline to its starting position, which is like, it's not,
Yeah. And would you do that for all the objects or just the ones that you know? Well, I mean,
so that's a great question.
Yeah.
Because I know what you're getting at, and the answer is it's kind of up to you,
right?
X and A,
and that's why I started backing off of me asking because it's like, all right, well, I was thinking the balloons wouldn't need state, right? Because the balloons are just there, but you end up interacting with them and popping them, so they kind of have to have some kind of state of whether they're being displayed or they just disappear,
right?
So,
and the way it's kind of up to you is how you implement your game. You could have scenes be the master of objects. You could have objects be their own sort of master with their own update and draw loops. And there isn't a right way.
Sure.
In fact, XNA supports something that we'll look at some point called game components, where you can build game components with their own update and draw loops, and then XNA will call those for you.
Oh, wow. Okay.
And again, that sounds like really appealing at first. And then some people, there's debate over like, well, is this the best thing? So in any case, let's say the game has started. That means we get past this. What we're doing when the game has started is we're updating the clown position and we're checking if it's hit our screen boundaries. But there's something else we should probably be doing. And it is we should check to see if somebody has been using the keyboard with the intent of moving the trampoline. So like I said, we have update clown position, right?
Mm-hmm.
So let's go ahead and let's see, where can we do this? I don't know that it matters too much, but I think what I'll do is I'm just going to put it right when we enter. In fact, let me put a little comment to note, like handle input and world update when game has started. So that's to basically say we never get here until the game starts. This is, again, this is kind of very hacker. So what are we going to do? I actually don't really need to get the keyboard state because I was smart and got it up here.
Okay.
So let's use that. If the left key is down, and the left key is defined as those arrow keys in the right bottomish of most keyboards, and we're just going to take the trampoline and move it 10 pixels to the left by taking the X part of its vector and moving it. And if you pushed right, it's going to be 10 pixels to the right. Why 10? As in a lot of game development, it just kind of felt good, and I played with the number until I liked it. Sometimes it's not the most scientific way to get to some of these things. You probably noticed last time that I wasn't like doing this complicated 9.8 meters per second calculation for physics. We just sort of figured out that we liked how this number felt.
Okay.
I'm also adding some code to say, what if they're using the gamepad? So if we have time today, I'll grab my gamepad, which is hooked up to the PC as well. And what if they're using the gamepad? I actually don't need to do this. I don't need to get it again. We already know that we have it from earlier up. If they're using the gamepad, well, then let's take how far they pushed the left thumbstick in either direction. We're going to multiply it by a value that felt kind of good. And that is what we'll move the trampoline on. Okay. And now that we've used both the keyboard and the gamepad to detect whether we should move the trampoline, we're going to do something that game developers are very familiar with, which is clamping. All clamping is a math term to say the number can be no less than this. It's like putting a vise down on a workbench.
Okay.
So XNA has a built-in math helper and a clamp function that restricts a value to be, it says it right there, restricts a value to be within a specified range. In this case, you give it the value, you give it the min that it can be, the max that it can be, and what does it do? It returns out either the value or the minimum or maximum if it had exceeded those bounds. Why am I doing this? I think that makes sense why I'm doing it, right?
Mm-hmm.
I'm making sure that the trampoline doesn't go off the screen. That's all. Okay.
Gotcha. Okay.
Go ahead. Now that I've done that, I'm going to go ahead and run it while you ask your question.
Yeah. So, and I think this is a more complex, but you've got those values in there, times 10, times 15. Do those values potentially relate to the device that you're running on? And you may want to have some kind of calculation that factors in the device and tweaks those for that kind of a setting.
Absolutely. Because this is a simple demo that restricted itself to, I think we set it to 800 by 600 last time. Yes, we restricted it to 800 by 600. These numbers remain static. They're definitely magic numbers that could be making you kind of sick if you're a experienced developer. But absolutely, you'll want to say when you're getting your game polished up to run on big screens, small screens, device, whatever, you're going to want to have exactly what you said is, I got to calculate all of these things based on the world that I'm living in. And games can run things different way. Some games can say, no matter what your screen size is, I'm going to make the game relative to that. Other games might actually say, oh, you have a big screen. Let's take advantage of it. Some fighting games, traditional fighting games like the Street Fighter, Mortal Kombat type.
Yeah.
Some games actually, the developers kind of say oh, you have one of those fancy widescreen curved monitors that have some ridiculously long X value for its width. You get this beautifully long arena to play in.
Nice.
You get to see more. But that's a game by game decision. So it may surprise you that we did all that work and update. Maybe it won't surprise you. This is a little bit of a trick question. And then when I start the game, we still don't see the trampoline. We did all that work.
The position of it, but did we add it to the scene?
Awesome. We didn't do anything in draw, right? We didn't do anything.
Yep.
So, and this is just to point out that this is going to happen to you. You're going to be working
exactly.
And you're going to be like, well, wait a second. I did all this work. It's oh gosh, forgot to draw it. So we're going to very simply draw it. It's not going to be that difficult. We already know we have the texture saved. We have the position saved. So right here in Sprite Batch, which has a begin and an end, we're just going to drop it in. We've got our clown. We're going to draw the trampoline, and that's it. We want you to draw it and don't do anything to the colors. That's what color white means. Don't touch it at all. Wherever the texture that we loaded above and the trampoline position we've been playing with, thanks to update. Now that I've done that, this isn't going to be super exciting, except for the fact that when I press the space bar to start, right now, if I'm pushing on left and right, it's doing nothing. And the reason why is because we fenced all that code in after game start. So I'm going to hit the space bar, and now I can move the trampoline around. It's not going to have any effect because we didn't code anything for this.
It's actually even going right through it when you look at the feed.
Right now, our code is just saying, just draw it. Don't worry, nothing else to do. But I can't push it past the left, and I can't push it past the right. So the clamp is working.
Nice.
And that's good. So now we need now this is where I think it starts to get fun. Now we need interaction. Okay. So how will we do that? Here's what we're going to do. This is, again, like everything else in this, maybe a little bit kind of messy, but we are now going to figure out where the clown and trampoline are in our game space. And we're going to create a bounding rectangle around each of them. Now,
Okay.
is that pixel perfect to be a bounded rectangle? It's not. I think for this game, it works pretty well. In some games, you actually do pixel perfect collision, meaning that if two of these sprites have transparent areas and only the transparent areas are touching, your game may be action enough or fine-grained enough that users would notice it and be like, no, I don't buy it. Otherwise, oftentimes traditional game development just drew a rectangle around a sprite. In fact, you might even now be thinking back to the games of our youth and think, well, man, that explains why Mario was kind of a short, stocky guy.
Like a box size.
like kind of boxy. Yeah. So it's very true. It's all absolutely true. So what we're going to do is we're going to put this code here where we're going to figure rectangles for clown and trampoline. And I'm going to use some other built-in X and A here. Let's see. Okay, so it's complaining about a few things, but that's okay. All I got to do is because in some of my previous code, X and A itself uses underscores for private variables, and so I kind of fell into that. I think modern 2025 me doesn't do that as much anymore. So in any case, let's just get all this in here. Hopefully this font isn't too small. I may zoom in just a little bit so we can see a little bit better. Okay. We're figuring a rectangle for the clown on the trampoline. This is part of the XNA framework again. Rectangle is part of it. You can create them, you can manipulate them, and they have some cool features that game developers will love. So all we're doing here is saying, using the current trampoline position vectors and widths of the textures, what is their current bounding boxes? That's what this is about. Now that we know that, we get to do this. We're going to do, this should be obvious what we're going to do next. We're going to say, check for collision with the trampoline. And we can do that with a helper method in rectangle. This is not the developing an intersection method isn't so hard. It would be part of your common game library, but XNA gives us rectangle has an intersects function that takes another rectangle and returns a bool. So you just kind of get that, which I think is really cool. Oh, I love how it's like, hey, I got an idea.
I think I've seen this before. Yeah.
Interesting. This is not my code, and it wouldn't do the same thing. It's setting a bounce angle. It is trying to figure out. It's figuring out a vector on that
X and Y
angle.
direction.
Yeah, it's just going to be 75-degree bounce every time. Instead of 90 would be straight up, and 75 would be off to the left, I guess, a little bit.
Yeah.
And it's just like, well, whenever it hits the trampoline, just bounce that way. That's not what I want.
Right.
I don't actually know if I still have the graphic. I'm going to feel terrible that I didn't think about this before we started, but I used to have this little graphic prepared where the way I want this to work. Let's go ahead and run the game so I can show you I can bring up the little trampoline. The way I want this to work is if you hit dead on in the middle, I want you to bounce back straight up.
Mm-hmm.
But the further you are to the sides, the more severe I want you to bounce. So this is not the actual math calculation, but you would bounce like that, and then you would bounce like that, and then if you're really, really severe, you might bounce like that, and then maybe somewhere around here, which it's not going to do today, you actually didn't make it, and so we would need like the clown to like maybe flip over and fall off or something like that. Instead, what you're going to see with the implementation we have right now, which is something we'll have to work on, is that you can actually like get all the way over here, and it'll like really bounce really severely, and it just looks kind of funky. But hey, this was demo code, right?
Yes.
This is what I want. So it turns out I wasn't the greatest math student, but this helped me learn trigonometry.
Oh, sure.
Because if I knew that this was 90 degrees, then I also knew that I could come up with a formula of how far away from the center am I? And then based on that distance from the center, I can decide what I want the angle to be. So this might be 90. Maybe this is 100, 110, 120, 130, 140. I could do that. And I ended up settling on the extreme edges being 135 and I forget what I said.
45 minus. It's 45, right?
I think it might have been 45 and 135, something like that.
Yeah.
And so basically I said, okay, the further away you are, the more severe you bounce. And once you figure out what you want that to be, I can use trigonometry to figure out, okay, well, if your vector was coming in, it actually didn't matter where you were coming in. If I want a vector that's going out at that angle, then what I really have, let's say I want it going out at this angle. I have a right angle triangle.
Yeah.
And which I'm drawing very, very well. And I have X and I have Y. So I can figure out what I want X and Y to be using sine and cosine, because in a right triangle, the tangent is the tangent of Y over X equals the angle, I think. This is going to be the hypotenuse.
Mm-hmm.
The sine of the sine of the angle is Y over X. And
Buckatoa, right?
And the and the cosine is it's not Y over X, it's Y over the hypotenuse and X over the hypotenuse for cosine, right? You're right.
Yeah.
And you know what's funny is I actually never really got very good with that acronym, but I remembered the Y over X part. I always struggled with the opposite and adjacent stuff. But the point is I'm like, this is the Y, this is the X, this is the H. So anyways, it was all something I was able to boil down into. If you've collided with the trampoline, then first let's figure out, remember I was talking about calculating that distance from center. Let's calculate our bounce angle based on distance from the clown center to the trampoline center. So the angle equals the center minus where the clown is plus 90, Y plus 90, because I kind of wanted the baseline not to be 0. If you are dead center, I want you to be at 90. Mm-hmm. I don't want you to be at 0. So whatever the subtraction of these values are is going to yield a negative or positive value, but it's a negative or positive value with 0 in the middle. I want the middle of the trampoline to be 90. So after I figure out that difference, I add 90 to kind of take it and flip it straight up. Gotcha. I hope that makes sense.
Mm-hmm. And I just because I mentioned it, there's a link to trigonometry and what SOHCAHTOA means.
Yeah, awesome. No, that's cool. I never had a better understanding of, and for the rest of my life after doing this presentation, I understand.
It retained it,
right now. It's game development. You struggle with math, become a game developer.
That's right.
Now,
or a musician.
What is? Oh yeah, I guess that makes sense. So what is factor? What is factor? Factor is me once again. It is once again saying, now that I have this harsh angle, I'm going to create a vector. In fact, maybe I don't. This will be easier to explain if I show the rest of the code.
Okay.
So this is the code that creates the new velocity vector right here. This is the code. Create new velocity vector, which is essentially, based on angle and scaled by factor. This is the code that matters. Don't worry about factor for now. What are we doing? We are taking the angle that we figured out. You hit the trampoline here. I want to bounce you away at a 67-degree angle. Okay, let's use our friends in trig to figure out what does that make the new X and Y for a velocity. What does it make that? Let's now set the velocity vector to that. But we scale it by a factor. Now, why? Because if we just make that calculation, we're going to get a unit vector and the clown's going to bounce 1 pixel away.
Oh, okay.
We need to scale it by the game world's physics, which earlier we started this whole thing off by saying when he hits the ground, let's just bounce him and let's do a bounce and let's multiply that by 700. And that gave us kind of a nice soft bounce that we liked. Right. So what the heck am I doing here? This is like the this is like the bounce factor to scale calculated velocity by game world size. Just to your point earlier, if we weren't in a fixed dimension, we'd probably want to calculate this instead of what you're seeing here where like this number works.
Right.
So generally speaking, if you hit the trampoline, I'm going to bounce you harshly back up if you hit it between 45 and 135. So that means you've hit the trampoline probably between the center and halfway to the left and halfway to the right. But if you get extreme, what I found is it made it almost unrealistically bouncy.
Right.
So you'll notice that if you're on the edges of it, if you're less than 45 or greater than 135, I actually say, nah, use a softer factor, 750. Huh. So he actually bounces ever so slightly softer. It is not actually all that visible to the naked eye. I could take that out, and then it might feel a little bit like, oh, yeah, you're right. That's kind of harsh. Listen, this is the fun part of it. This is where you play around with things to make it feel the arcade style that you want.
Mm-hmm.
Now that I've done this, I have checked for collision with the trampoline. I've calculated the bounce. I've figured out what I want my new velocity vector to be, and I've set it. We do one last thing. We go ahead and we exit this portion of the code, and we allow the game to continue with its gravity simulation, where what we do every frame, no matter which way you're going, is we tug on you downward. It's like you've got a rope on the clown, and we can just pull it a little bit.
Yeah.
So let's see. Let's see if I got all that right. I don't have to change drawing code.
No.
Right?
No.
So let's see. I'm going to hit the space bar. And oh, actually, wow, that was crazy. He squirreled away. So let me think about what the heck did I do?
Is the trampoline rectangle right?
Let's see. Trampoline rectangle, clown wrangle. And, let me see. What did I miss? Oh, yeah. I did miss something. It turns out, and unfortunately, we don't have that vector indicator up.
Okay.
The vector that comes out of this calculation is so he's coming down, and we figured out that he should either bounce away this much to the left or this much to the right, but I never flipped the Y value.
Oh, okay.
So he did bounce to the left, but then he
in a positive direction.
Yeah. So it turns out that we need a little flip. We need a little flip of that Y value. Smarter math people than I might be saying, gosh, you could do this all in one line of code. What's wrong with you? And this is a little bit of a clamp. Did you notice how he seemed to phase through the trampoline?
Yes.
To keep him above the trampoline. Now imagine we are pulling him down 16. In fact, I think we can just show it. We're pulling him down 16 pixels every frame. That doesn't mean he's always going to line up with the trampoline perfectly. In fact, when we detect that it's intersected with the trampoline, his part of his body might be partially in the trampoline.
Sure.
So I have to do something about that. And let's say I don't. Let's say I don't do it. I think we're going to see that. I think we're going to see that this looks funny. Actually, it really isn't so bad. Well, for one thing, he did he disappeared. We're not holding him in, apparently. So let me add this little clamp. This is not using the clamp function. I think I could have, but I probably was up at 3 a.m. the night before the Flea.net presentation or something. And so this is a clamp to keep him above the trampoline. I thought we had boundary checks.
So a clamp function for the clown as well?
Yeah, because we need him. Oh, I understand why. I think. Yeah. You know what we don't have in here is we came up with these boundary checks, and then we did the detection for whether he hit the floor, but we have no detection code for whether he hits the sides. We don't have any.
Gotcha. Okay.
So we can very quickly add that. And sorry, this we could have done before. But you know why we didn't notice? Because we didn't have him bouncing off a trampoline.
He wasn't going any directions, yeah.
Yeah. So once again, we can we can say this is a little, we could probably have used clamp for this as well, but I have a feeling that it must have been, I don't know why I didn't think of it. We probably could use clamp. I mean, why couldn't we? Why couldn't we clamp? You've hit the right side, so you can't be any less than that. Anyways, the point is, if its position is greater than our calculated max, which was our calculated max is a little bit less than the entire width of the screen because the clown himself has width. So we don't want half of his body going off the screen. His whole position is based on his upper left coordinate.
Okay.
So if we don't do this, if we don't take into account his width, then only like half of his body all of his body will go off, and then he'll bounce, right?
Yeah.
So we have to account for that both on the right side of the screen and the bottom because of max. So this essentially clamps him to the right and the bottom. This is our little death detector, except that right now he's not quote unquote dying or losing a turn or whatever. He's just bouncing. And I think we finally now have, we also are clamping him in a way so that he can't be caught halfway in the trampoline. I think finally, we will have what we want, which is, and you can see if I don't quite get him on center, he moves around. And then this is where it gets, when he hits the sides, man, that's what I'm talking about. That how it just feels a little unnatural for his bounces to the left and the right, I think. But that's okay. We could play with that. So when I was doing this talk, I would always say, so now we have our toy, right? We're not going to write code that's too much more complex than this. It's just going to be detection with objects now because we have this sort of bouncing thing. Yeah. We have this bouncing thing in place and it works.
Yeah.
So we don't have that much time left, but I think if we hustle, we can do it.
All right. How far do you want to get?
Well, he needs something to bounce into.
Sorry, so we got to do the balloons then, is what we're saying. So we bring in the balloon image.
Right. We're going to need an image to bring in. So let's add an existing item. And
to the one in the TDTS, right?
Yeah, you're right. I'm always in the wrong spot here. Probably, and I understand why, because it's like, okay, so this is like my little off-screen thing. We're going to copy it to the folder. Balloon is fine. We haven't looked at balloon yet. We haven't looked at it yet. Balloon is not the same as the other ones.
Oh. Balloon is a sprite?
This is what we call, this is one form of a sprite sheet.
Okay.
Where we have to save. This was especially important in the early days when we didn't even have graphics cards.
Right.
To save on loading and unloading into video memory, we might just load this whole texture in. And then what we'll do is we'll pick what rectangle we want to draw out of this.
Okay.
It's very maybe difficult to tell, but these balloons are supposed to look like they're floating because the string changes.
Yeah.
So that's how it's supposed to look. So anyways, and we've got to, I guess we got to get moving. So yes, I always forget to do this. I need to save the project. I need to build. And now we need to get everything imported. So I'm probably going to be doing a little bit less. We're going to zoom through this a little bit, but hopefully not too quickly.
Right. And it's stuff we've already done. We've added things to our, we're going to add the balloon object to our stage here.
Yep. So let's get a balloon texture in. Boy, back then I didn't use the private keyword very much, I guess. So funny to look at code that you wrote a very long time ago and say, wow, I'm different. Load content. We need the balloon texture. And then I actually, let's see how this goes, because I wrote a method to set this up.
To kind of create that array of balloons?
Yes, I did. And so it looks like if I go outside all of our 4 methods, I think this will be something we refactor into a better set here, where I basically say, we're going to create a balloons list. And we're going to say, I want 3 rows. I want 21 columns. Here's how much far apart I'm apart. And all this thing is going to do is calculate a list of balloons based on my little specification.
Yep.
So in other words, we're going to need a list of balloons, which I did not create. So we'll say, we'll come back up here. Here's the balloon texture. And list of balloon. Oh, we don't even have a balloon class. Right. I forgot. I have a balloon class. Oh boy. I hope I wasn't too ambitious here. So clearly, I was not doing a good enough job. Like, why not reuse the sprite class? I'm not sure why, but let's go ahead and add a class and call it balloon. And there it is. And we are going to cut and paste something in here. Let's take a quick run through it. So what is a balloon? A balloon has a position. It has a bounding box, probably so that we don't have to calculate it every time. Let's just figure out what it is. It has a color. This color is an integer. So it's not like you'd think. It's not like the other colors where we've declared red, blue, and green. What this is doing is this telling this class, which one of those color balloons are you?
Oh, okay.
Right. And then this actually keeps track. This keeps track of its own time to switch by passing in game time so that it figures out when to show you which of those two balloon states. That's what this was all about. We could wrap this into an animation class so that it would be more generic. But clearly, I was either in a hurry or, as I said, it might have been 3 a.m. the night before my Philly.net presentation. That is always possible. So let's see if this builds. It doesn't because something's okay. I think when I brought in the balloon class, I wasn't totally complete. I missed a curly brace, and now it's going to build. That's not going to do anything because we're not drawing anything. We're not, none of that is happening. So we need to draw the balloons. And what I'm going to do is I'm going to go to the draw method, and I'm going to say, right after we draw the trampoline, we're going to run through the balloon list, and we're going to call sprite batch each time for every one of the balloons that we set up balloons. And we're going to say, well, let's draw the balloon texture. Let's draw the position. And then we'll use balloon state, whether it's 0, 1, or 2, to figure out where we should jump in that sprite sheet. Should we start in the upper left? Should we be in the upper right? Or if you're the second color balloon, then you're in the middle, and the third color balloon, you're at the bottom. And depending on your state, should we be taking the image we saw on the left or the image on the right? This is just a really hacky way to basically be like, which one of those 6 balloons am I drawing in this spot at this time? That's all that is. We never called setup balloons either. That's why the code's telling me, it's like, why do you even need this method? Like, you're not using it. So I'm going to go back to initialize. And we're going to say, oh, it's even figured it out. Now, I think this is enough to get them drawn. I think. Yeah, here we go. It's enough to get them drawn. We have no update code, right? 0. So we're not going to actually do anything when he makes contact, right? But we're drawing them. So that's cool. If we look really closely, you might also notice that string is not seeming to animate. And that makes sense too, because we're doing absolutely nothing in update. I don't know if you're muted, by the way. You might not be. I just hadn't heard you in a little bit offering an answer. So
my microphone apparently has run out of battery.
Oh, okay. All right, I can hear you now. Okay, now it's garbly.
Just a sec. Is that better? Not really.
Softer. It's softer garbly.
Softer garbly. All right, hang on one sec.
Okay, so I'm going to move forward and get the update code in, and when Rich is ready, I've muted you on StreamYard. Unmute yourself when you think you got it. So I'm going to continue ahead because what do we need to do? There's a couple things we need. We need to update what happens when he hits balloons, and so we're going to add let's see, right after we do the trampoline check, we're going to do a balloon check. And the way we'll do a balloon check, it could seem a little brute force, and it very well might be, is we're going to go through that balloons list and see if and when the clown intersects with them. Each balloon has its own bounding box. So we know where it is. We can very quickly say, did the clown intersect with this balloon, this balloon, this balloon, this balloon? We will come back to printing a score because we clearly don't have that ready yet. If the clown is intersected with a balloon, we're going to remove it from the list. It'll stop being drawn. What we're going to do is, just like when the clown hits a wall, we're just going to reverse the vector. So however fast it's going, whatever direction it's going, it's just going to reverse. Bam. So it bounces off. And then I did this as part of, like, I don't even know how perceptible it is. I added a little bit of jitter to him. And the idea was to try to simulate it not just being this very predictable bounce off of the balloons. So yeah, we're still getting a lot of garbage from your mic, unfortunately.
Okay.
So, and then we'll worry about this a little bit later. I've got a little note here saying that you can only delete one balloon per frame. So if we actually find one, we break. And that was because I'm using a list and using remove at, which is kind of tweaky, and it would blow up. And it turns out that I actually didn't mind what it did for the gameplay. So, I mean, you know, kind of funny stuff. The other thing that I think is not happening, let me think, what else is not happening here? There's, I feel like we need to call another method. Yes, we do. Our balloon class has this silly little method, update animation. The only thing this method is doing is that we keep feeding it elapsed game time, and it's figuring out whether or not the balloon is in state 1 or state 2, and that's to give that string that little, like, a little bit of a flighty appearance. So we're just going to call that here. Not the cleanest way to do this. We'll refactor this at some point. But now what you're going to see once the game starts is, if you look really closely, or if you download this code and run it yourself, first of all, we got our first pop when the clown hit. When I finally am good enough to actually hit the balloons up there. As you can see, I'm terrible at this game right now. Woo! I can't even keep up with it at all. I actually do get better at it, but not today. Oh, look at that! Look at that! Some other stuff we've got to work on. I was able to trap him. So there's a lot of work to do to make it game ready, but there we go. We're actually, our game's in progress. The string up there is actually animating. That's all happening. We will do some stuff next time, like adding sounds. We'll keep score. We'll make the background a little more exciting, but we're kind of on our way. We're kind of on our way. We've definitely got a lot of work to do for it to be game ready, to avoid things like, now I can't do it. To avoid these little scenarios,
right?
Because those are kind of messy. One thing you may notice, especially if you're a game developer veteran, is does it look like the pink balloons, like Pac-Man got to it, and there's a bite taken out of it? Yeah, this was a happy accident for somebody who's presenting on game development. It turns out that, historically speaking, remember I talked about how we didn't have transparency in our image formats back in the day?
Mm-hmm.
So traditionally, this was just tradition. Traditionally, the color magenta was used in graphics files to represent all the transparent pixels that we didn't want to draw.
Oh, wow.
Then you would build your game engine, and you would just never draw magenta. Why magenta? Why this color magenta? I think game developers thought no one would ever use this in a game. It's ugly.
Right.
So
until you do.
And it turns out you could do clever tricks with video RAM back then, because remember, game development way predates GPUs.
Yeah.
And so you would do this trick where you would be able to say, once when you loaded these in, you just wouldn't load the magenta into video RAM, and then you never had to worry about it. XNA offers what they call a key color. Very much like a green screen, you use a key color for your green screen. And because the traditional key color for game development was magenta, it is magenta by default.
Oh, okay. So this is like setting your green screen color. Okay.
Right, it's setting the green screen color, but it turns out that this balloon has magenta in it. So do I have to change the balloon? No. I can go into XNA and I can say, you know what? Don't enable the key color for this particular piece of content.
Okay.
So you have flexibility. You don't have to do it for your whole engine. You can just do it for this piece of content. So now that I've done that, save it, build it, and then run it. I think the little munch. Oh no, the munch is still there. So clearly that wasn't the only thing I had to do.
No, it wasn't the trampoline. You were highlighted the trampoline.
Oh, so did I? Thank you. I picked the wrong thing. All right, so it doesn't matter what I do there because there actually is no color key. So balloon. I'm glad you noticed that. Color key enabled is false. That's interesting that there's multiple coming up here. Is that a bug? I don't know. Is it going to do what I wanted it to do? No. Why were there two? I don't know the answer for why trampoline has two of these. So okay, now it says false. Save it. I don't know if I actually have to. Yeah, okay, it built it. It built balloon PNG. It built trampoline. Color, okay. Color key doesn't matter for the trampoline. Now that I've set that, and we bring it back, and that looks a little bit better. Let me zoom in with the game running so you can see the little string a little bit more clearly.
Yes.
That is that. Let me back out of here because I imagine we are hitting our end time.
Yep.
And what I'm going to do is I've got a gamepad here.
Ah, there we go.
We already saw that there's gamepad code in here. Let's see if I'm any better. I'm going to hit start and I'm playing the game with my this happens to be an Xbox Elite controller. Does not have to be. It's just a gamepad hooked up to Windows. Doesn't matter what it is.
Right.
And so
that's awesome.
We have our game. It's in motion. Next time we'll do some like polishing off to make that pretty background, add some sound and music, keeping score, and then maybe we'll do some refactoring. But I hope that this this should be what we're looking for. So
very cool. Very cool.
Let me I'm going to get the GitHub repo in chat while we finish up here.
Yeah.
Oh, your microphone's great, by the way. You've got that all fixed.
Well, I went to the headset or the earbuds, but yeah, whatever that charging thing does messes with the audio. So that was great. We got to see a game that's working. It's working with the keyboard, with the pad, and we've got some things lined up for next time as well. So so thanks, Chris, for walking through that. That was pretty cool. I like this topic. There's some cool stuff that I'm dying to get into, and been thinking about, hey, is there a way to, because when we do this, do different kind of demos, we often bring in Copilot to say, hey, let's start from scratch. It'd be cool to do a game like this from scratch and just kind of see. Now, assets are challenging and things like that, but that's kind of where my mind's going. I'd love to hear where your mind is going when we start thinking about this topic and how we might be able to ask questions, how you might have questions, or think about different things you want to do for this. So drop them in the comments below. Again, we are out there on this one, out on the YouTubes. So thanks for watching. So with that, we'll kind of wrap things up for today. Come back soon, and we'll do some of the things that Chris mentioned to kind of finish out initial working of our game. So thanks everybody for watching, and we'll see you next time on Dev Talk Show.